Good morning. My name is José Alberto Castañeda Vía from Universidad Nacional Mayor de San Marcos for Peru. And I'm going to present this work entitled A Theoretical and Experimental Study of Ytterbium-Doped Hydroxyapatite Structural, Morphological, Chemical, and Mechanical Properties. The Sorgel method was used to synthesize pure hydroxyapatite and one doped with 10% molar ytterbium, precursor solution of calcium nitrate and ytterbium, and ammonium phosphate were prepared and precipitated under magnetic stirring, adjusting the pH to approximately 10.5. After a day's rest, the gels obtained were washed at least 3 times under centrifugation to remove residues, and the samples were hydrated for 3 hours at 400 degrees Celsius. X-ray diffraction showed the pure phase to be obtained in both samples, with the doped hydroxyapatite having the smallest lattice parameters, but a slightly larger crystallite size. The grains were irregular in both samples as observed by electron microscopy, and EDS showed a molar radio of 1.4 in the pure hydroxyapatite, i.e. deficient in calcium, while a molar radio of 1.9 was observed in the doped hydroxyapatite, i.e. deficient in phosphorus. FTR spectroscopy revealed some difference between the samples' vibrational modes. Both samples contain carbonate ions in their structure. However, the Doppler sample has significantly more. The main difference is observed in the shift of before bending vibrational mode of the phosphate group, which shifts to a frequency of 722 due to lattice distortion and OH vacancies generated by hyperbium doping. The ultraviolet visible spectra were transformed in tau plots to obtain the band gap energies. Pure hydroxyapatite had a band gap energy of 4.87 electron volts, while doped hydroxyapatite had a band gap energy of 3.47 electron volts due to the presence of localized 4F electron state of ytterbium. Nanoindentation tests were performed using atomic force microscopy to obtain some mechanical parameters. It was observed that the stiffness, hardness, and elastic modulus increased with doping, probably due to the ytterbium ions acting as breaking point for dislocation propagation in the crystal lattice. Density functional theory, DFT, calculation were performed to compare the data obtained with pure hydroxyapatite, finding that these underestimate the structural values. Furthermore, the density of electronic state was calculated, revealing a bandgap energy value of 5.19 electron volts, close to the experimental values. The density of phononic state obtained by phonopy allowed the IR and Raman active bands to be obtained, which is also in good agreement with the experimental data. Finally, the mechanical parameters calculated by thermo-PVW in the Boyle, Reus, and Hill approximation were significantly higher than those obtained by AFM, because these parameters consider the sample as a single crystal. Some conclusion already mentioned above, and thank you very much for your attention.